Hello everyone, so we have today LeetCode problem number 514, Freedom Trail. If you watch this video till the end, you will understand this solution no matter it's rated hard. Okay, so if you want to read the problem, pause the video and read it. I will explain it through an example. So in this problem, we are basically given two strings, ring and key. Okay, so what this ring is, this ring we can rotate anti-clockwise and clockwise, that is in this direction or in this direction. For every one letter that you rotate it will be counted as one step. Okay, so if you rotate it, that will be one step. And when you rotate it and the top element, that's what it means by the 1200 direction. If the top element matches the key, you can enter the key by pushing this button. Okay, so by pushing this button, it will also count as one step. So pushing the button will also be counted as one step. Okay, so in this particular example, we are given the ring as Godding and key as GD. So the answer to that door is GD, which we have to spell. We have to push it letter by letter by rotating the ring either clockwise or anti-clockwise. Okay, and also here we are given the first letter as G in the key and our top of the ring is G. So we don't need to rotate it. We just push the button. So we have entered here G. So G is entered and now we have to enter D. So if you look closely, you have D here and you have D here. So the shortest possible, for the shortest possible path or the least number of steps, we can rotate it this way. Okay, so we will rotate it twice. Why twice? Because first time when you rotate it, this O will come here and this D will be here, and then if you rotate it again, then this D will come at this place. Okay, so what we will do is we will rotate it two times. So two times rotation, we will rotate it anti-clockwise two times, and then we will have to press the button also to enter the key. So the third step will be of pressing the button. So our one step was taken by this G and this D is taking these three steps. So the total number of steps that we required is 4. So the answer to this problem is 4. So we will be looking at the top down, bottom up and space optimized solution of this problem. You will find the links to all of these codes in the description and in the comments. So now let's move on to the approach of this problem. Why greedy approach will not help us in this question and we will have to go with dynamic programming. So let's say we have the ring here as G, I, N, and here is another N, then O, 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 O and P. So we have this ring here now. So we want to make the key as NP. So if you go by greedy approach, so you will first rotate this ring clockwise direction. So that will be one step. Then N will come at top and you will need another step to push the button. So this will be two steps. And now you want P. So when you rotate this by one step, N will come here, our N will come here and our P will come here. So now you will have to rotate it in this direction. And how many times? 1, 2, 3, 4. We have to rotate it 4 times. So if we rotate it in this direction 4 times, so 4 steps to rotate it and 1 step to push the button. So the total will be 7. But we know this is not the correct answer. The minimum number of steps will be, if you don't go by greedy approach, and rotate in this direction. So if you rotate it in this direction, so we will have 2 steps to rotate N here. So our N, this N will come here and this P will be here only because you have rotated it 2 times. So whole ring will rotate. Now we will have 2 steps to rotate N and 1 step to push the button for N. And now for P, we just have to rotate it once because P is here only now. So we have to rotate it just once and 1 step to push the button. So our total will become 5, which is lesser, and that's the correct answer for this question. Okay. So now let's see the recursive approach to this problem. In recursion, we will make a solve function. So let's say it's solve. It will take the argument, the first ring, second key, and 2 integers I and J. So I is basically to traverse the key. So I will traverse the key and J will be the current index in the ring, in the string ring that we are sending. Basically, it's the top or the 1200 direction character in the ring. Okay, so now first we like the base case. So the base case to this will be if our key, if our I goes out of bound of key. So if I is equals to key dot size, then we have no more characters to be pushed in the door, so we will return 0 from here. So return 0. Now here two case arises. Either this element or the jth element is equal to the ith element of the key, that is they are aligning. The character that we want to spell is at the front direction or at the correct position in the ring in the 1200 direction. So what we will do is we will return 1. Okay, so the condition would be if key is equals to ring, sorry, key of I is equals to ring of j, then what we will have to do is we will have to return a 1 plus, we will call the function again for the next I. Okay, for example, for this g, this was equal, so what we did was we return 1 because we have to push the button. This 1 is here to push the button, this 1 is here for pushing button, and then we move to the next I. Okay, so for next I we will write solve ring key and increase our I by 1, and we will send the j. Okay, so in the else case of this, if we will have if they are not equal. If they are not equal, then we have two possibilities. Either we have to rotate the string left or we have to rotate the string clockwise. Okay, so what we will do here is that if we have this string ring here, and so let's zoom in here, which is godding. So what we will do is we'll place j, for example, first here. So our j is first here, then we will for moving it clockwise. Okay, so for example, this was our g o d d I and g. So for moving it clockwise in this direction, we will have to move our I in this direction, that is in the left side. So we'll have to do here I minus minus or j minus minus, sorry. So this will be our j, then we will move it to here. Okay, and then for moving it again clockwise, we will have to j to be moved here. Okay, so what we are doing is j minus minus, and we will maintain the case when it goes negative, we will again push it back to the end of the string. Okay, now to rotate the ring clockwise, what we will have to do is for rotating the for rotating the ring anti-clockwise, that is in this direction, what we will do is we will move the I here. We will move the j here because the ring will rotate in this direction, so this will come on top, so we must rotate j in that direction. So we will do here j plus plus. Okay, so one thing that we have understood is for moving anti-clockwise, what we will do is j plus plus, and for moving clockwise, what we will do is j minus minus. Okay, so we will make two functions for rotating our j clockwise and for rotating our j anti-clockwise until we find the current ith character of the key. Okay, don't be overwhelmed, we will look into it now. So let's move it to the else case of this problem, of this condition. So else what we will have here is else thus the current I and j are not equal. So if they are not equal, we have to rotate it. So we will have a function, we will have two functions. Let's say rotate anti-clockwise and rotate clockwise. The rotate anti-clockwise function gives here us two values. So we can say that they are returning a pair. So what they will return is the number of steps taken to rotate anti-clockwise and the current jth position. Okay, and the current position in the j where we find the character which is equals to the current character of g that we are trying to match. And in clockwise, similarly, it will return the number of steps and the current position of j. Okay, so let's say we have a pair p and we call the function rotate anti-clockwise. So we call rotate anti-clockwise over I plus 1. We will call this over ring the j, which is current index, the current top element, and the character ch. What this ch is the current element of the key that we are trying to match. Okay, so it will rotate J in ring until it finds CH. Now what we have to do here is we have made the pair, so we'll make a call to the rotating it left and then matching the character. Okay, so let's say int anti-clock, let's write it just AC, so it will be solve ring key I plus 1. Let's say we have matched it, so we move to the next direction as we have rotated it, and now we have made the top element same, so we will move to the next character in the key, so we will increase I, and then we will send here p dot first. Okay, p dot first as in, this is our p dot first, this J, the position of J now, the position of top. Okay, p dot first, and we will add in this solve function, what this solve function return will be for the next iterations, but in the current iteration we will have to add the number of steps that we took to rotate it, so that will be p dot second, and that will be p dot second, this one, and we will also have to add here one because we will rotate it and push the button, so that will be 1. That's how we have matched the character and entered into the gate. And now similarly what we'll do here is we will make calls to the clockwise. So now our p will be rotate clockwise, and it will take ring J and CH, and it will rotate it clockwise. So we'll make another variable, say clock C, in which we will call solve ring key I plus 1 and p dot first, and in this we will add the number of steps taken to rotate it clockwise, p dot second, and 1 step required to push the button. Okay, so this is what our solve function will look like, and in the end what we will do is we will return the minimum. We will return minimum of our anti-clockwise and clockwise. Okay, so this will be our else part. So now the code is complete, but this recursive function will give us TLE. Okay, this will give us TLE, so we will have to employ DP here. Okay, so first let's see the top-down DP. For the top-down approach, we will make changes only in the recursive function itself. So the one change is that we pass here a DP array. Okay, so also one thing to notice here is that we had this I and J, and these both were changing in the calls. Okay, as we can see, these both were changing in the calls. So what this signifies here is that this is a 2D DP problem. So this is a 2D DP problem. So now first what we will do is, after checking the base case, we will check if it is possible for us that the answer is stored in the DP array from the previous calls. So what we will call here is, if the DP of ij is not equal to -1, then we will return DP of ij. This -1 is nothing but a number that we initialize the DP array with. So if it is initialized that it is -1, it means that for that particular I and j we haven't stored any value. Then what we'll do is we will return the answer if this is not in the DP array, but while returning we must store that value in a DP of I and j, so that in future when calls are made, we don't have to make the call for it again. We can get the value from this statement only. So DP of I j is equals to this, so we will return this now. And similarly here, instead of just returning, we will have to return DP of ij equal to minimum of them. Okay, also in the calls you will have to add another argument DP and change this solve to solve mem. Now that we have understood the top-down approach, the tabulation approach will be really easy. We will just reverse the what value we passed in the function and what we return. So we will call this function by I0 and J0 in the memoization through the driver function. So in this tabulation, through iterations, we will start the I from the end of the keys array. So what we'll do is, for int I is equals to the key dot size minus 1. So what we are doing here is, in memoization we had I is equals to 0 and we went till I is equals to the size of the key array, and we started with j is equals to 0 till j is the value of j actually is rotated, so it does not matter, but let's say it goes to ring size, and this is key size. So in the tabulation we just have to reverse these. So in tabulation what we will do is, we will start from here and go till here, and we'll start from here for j and go till 0. So for I is equals to key dot size minus 1, and then we will have our I is greater than equal to 0 and I minus minus, I minus minus, and in that we will traverse j for int j is equals to ring dot size minus 1, and our j should be greater than equal to 0 and j minus minus. Also we are not passing the dp array here, so we can make a dp array in this function itself because it is not recursive. Okay, so our dp array will be here and we will initialize it by 0, because in this case we will initialize it by 0 because first, if you look at the mechanical way, then if you see the base case in the memoization, you can see that for I is equals to key dot size we are returning 0. So what we can do is, we can initialize the whole array by 0. So the base case we don't have to initialize the dp array again with the respective base case. Okay, so we will initialize it by 0, and then in these loops, in these both two loops, what we have to do here is just copy the logic of the memoization approach. So our logic of memoization approach was this: we will ignore the dp the checking answer in the dp array, we will just copy the actual logic. So our actual logic was starting from here and then till the end. So we will copy it. We will just make the changes in calls. Okay, so first, instead we will not return it in the loop itself, we will copy the we will store the answer for each dp of I and j, and that will be stored in dp array, and in this function itself, after making the iterations, we will return the dp of 0 0, because just remember one thing, whatever we pass in the memoization, that is what we return in the tabulation. Okay, so now we will replace these. I'm using yellow for the tabulation, so we'll replace this calls by the dp array itself. So it will be dp of I plus 1 and a p dot first, and similarly here it will be I dot first, I plus 1, dp of I plus 1 and p dot first, and here also it will be I plus 1 and j, so dp of I plus 1 and j. Also one thing to note here is that we are starting I and j at index minus 1, and in the dp array we are going I plus 1, so that will go out of bound, that is one size after the actual size of array. So while initializing the dp array, we will have to make the rows as number of rows plus 1 of ring, and for columns we are taking the I, so for key we will have also increase it by 1. Okay, otherwise it will give us a runtime error. Okay, so now we have seen the tabulation approach, and from tabulation approach we can see that the dp of I depends on I plus 1 here, also dp of I here also depend on ac and c, and if we see c and ac, they also depends on I plus 1 and I plus 1 also. So we can say that for every I, the for dp, the every ith row is dependent on the I plus 1th row, so it is only dependent on the row in front of it. So what we can do here is, instead of making a two-dimensional dp array, we can do it by two vectors of size that of I, that is the key, so key dot size, so sorry, ring dot size, because the j will be the number of columns and there will be only two rows that we require, so we can do this by two vectors. Okay, so if you want to understand it better, you can see the previous video to it where the solution was made using two vectors. Okay, so now let's copy it. Now we will just make changes in the tabulation function itself. So first of all, we will have to make a dp array, let's say current, which signifies the dp of I, and dp of I plus 1 row will be depicted by our let's say the vector to be next. Okay, so that will be next. So just change the dp of I by current and dp of I plus 1 by current, and after this for loop, and before we will just have to switch the values of current and next. Okay, so let's see how we'll do this. It's by changing this dp of I by current and this dp of I plus 1 by next, and again for this we will say next, as it is dp of I plus 1, this will also be next, and then this will be current. So our function is nearly complete. What we have to do here is just add a line between these loops. So let's move it down a little bit. So what you have to do here is just add this line, that is our next is equals to current, because as we have made the computations for the next vector, we just have to copy down the value of current vector into the next vector for the next iteration. Okay, so these were all the approaches for this problem: the top down, bottom up, recursive, and space optimized. The best one in this problem will be the top down approach. If you want, you can see this by submitting all the approaches. The top down will give you lesser runtime because it is making only the required calls and the iterations are going for all j, and we don't require that because we just have to rotate the j at the current position. Okay, so thank you, bye bye.